Welcome to the first episode of my Olympiad Maths lecture series. This series aims are covering the variety of topics aimed at training students for maths competitions. One key feature of such math problems is that calculators are not allowed to during the solving process. Let's begin the series on the topic of trailing zeros. The objectives of this lesson will be for the students to be able to count the number of trailing zeros for large numbers. So let's begin with the definition and some examples of trailing zeros. Trailing zeros refers to a sequence of zeros in a number such that no other digit follow behind the last zero. In the first example, the number 4200. You can see the number ends with two zeros. We can say that there are two trailing zeros. Here an example, the number 109,000 is with three zeros. The zero between the 1 and 9 is not counted because the number 9 follows behind that zero. We can say that this number has three trailing zeros. Let's look at the number 500,200,000. How many trailing zeros are there? 5 trailing zeros is correct. The two zeros between 5 and 2 are not counted. So let's look at our first maths problem. Find the number of trailing zeros for 2017 factorial. This exclamation mark refers to the factorial function. This is a huge number when with a normal scientific calculator. Your calculation is likely to give up on. With the computer you could calculate it, but it's very unlikely any students is going to be able to retrieve this answer. This actual number comes up to 5,792 digits. There is a huge chunk of trailing zeros attached to it. They have highlighted in red. So the question is how many of them are there. I am going to answer the post this video here to think through the problem before you view the solution. So one strategy that we can employ to solve this problem to the first look at the easier case in this problem. Let's look at the 10 factorial. 10 multiplied by 9 multiplied by 8 all the way to 1. We know the basic math that if you multiply anything by 10 you would get the trailing zero. So 10 factorial would have at least one trailing zero, but if we look closer, 2 multiplied by 5 will also give us 10. So 10 factorial would actually have two trailing zeros. The problem is then reduced to how many factors of tools and advice are there in 2017 factorial tool. To simplify the problem, we can ignore the factors of tools because they occur just far more commonly than the fives. We will just look at the factors of fives. So let's carry out the plan. Since there is multiplied by 5 every 5 numbers, when we just divided 2017 by 5, round it down. This symbol that I am using just in case you are not familiar with. It is the flow function which basically means to round the number round with nearest integer. 2017 divided by 5 gives us 403.4 and round it down it 403. All quite double without a calculator. So answer is 400 and trailing zeros. 403 would be wrong. It turned out that for every 5 multiplies of 5, there is a multiply of 25 and 25 is 5 squared. So it has two factors of 5 in it. This is right the two trailing zeros when multiplied by 4. So if we divided 403 by 5 and rounded that down, that tells us there are 18 multiplies by 25 such contribute the extra zero. What we done? 125 or 5 cube will generate 5 trailing zeros that multiply by 8. 625 5 to the power 4 will generate the 4 trailing zeros when multiplied by 16. So look at the final answer. In total multiplies of 5 produce 403 trailing zeros. The multiply of 25 produce additionally 18 zeros. And multiply by 100 inside produce extra 16 more than 0, and finally multiply by 625 at 3 more trailing zeros, and top of all that gives us a total of 502 trailing zeros. So there we have 217 factorial has 502 trailing zeros. Here are some problems to extend your learning. This concludes our first ever Olympiad maths lecture. Please leave a comment below and hit the subscribe button if you like to learn more about mathematical problem solving strategies. Thank you for your kind attention and have a good day of learning.